All right, now that we have talked about how important units are to your answers, right? Putting it in context. So remember, anytime this semester that you have a number, you need to have a unit that goes with it. So now that we know about those units that we've studied in a previous lecture, we are going to talk about how we can manipulate those units. So we're going to learn about derived units, and then we are going to study our first derived unit, which is density. So let's start by saying, what is a derived unit? A derived unit is simply a combination of base units. So let's remind ourselves, what was a base unit? That's your basic measurement, something you can directly measure. So for example, we can measure length, such as the length of a table. That is going to be in meters. We can measure mass. What is the mass of an object? We can measure that. We could put it on a scale and we can measure that. That's going to be in grams, etc., etc. Okay, so that's what we've talked about before. Volume is an example of a derived unit because you have to measure the length, the width, and the height of an object and multiply those together to get a volume. So volume is not a direct measurement, right? It is a measurement that we get by combining multiple base units. In this case, multiple measurements of length. Okay, here in the yellow box, this is a really, really important conversion factor. It's going to be very helpful all throughout the semester, so definitely make sure you write this down, highlight it, put a star on it, something like that. 1 centimeter cubed is equal to 1 milliliter, always. Okay, that's a very important direct factor for you. So I highly suggest right here at the beginning of the semester, go ahead and get a sheet of paper that is going to be your equation sheet, because as we go throughout the semester, we're going to learn a lot of different equations. So it's really helpful to have them all in one location instead of all in the different sections of your notebook. That way we can use them. So I suggest either gluing it into the front of your notebook, paper clipping it into the front of your notebook. If you have a 3-ring binder, just make it the very first page and just have this growing equation sheet as we go throughout the semester, okay? And I would put this right there, this conversion factor, right at the top of that equation sheet, okay? Then the next thing that we're going to put on that equation sheet, our very first equation, is going to be density. So density is a derived unit. It is a combination of 2 units. It's a combination of mass and volume, okay? So density is your mass per volume. This is a measurement of how close together the atoms are in an object. So if an object is very dense, the atoms are very closely packed together. It's very compact. Versus something that has low density, the atoms are more spaced out. So items that are dense tend to feel very heavy because of how densely compacted their atoms are, while items with low density tend to feel really light if they're both about the same size that you're comparing, just because those atoms are more spread out. Okay, so that is a measure of density, a measure of how closely packed they are. Okay, so here is our first equation that we're going to put on our equation sheet. D equals m over v. So here's how I would start to set up that equation sheet. I would write my equation where it's very easy to read. Use your best handwriting because you're going to be using this all semester. You want to be able to read it, so use your best handwriting. Write the equation. Then, either next to the equation or below the equation, write out a key. Okay, so the D in the equation stands for density, the M in the equation stands for mass, and the V in the equation stands for volume. That way you know what kind of information that you're looking for to be able to plug this in. I also recommend in parentheses or next to these letters and descriptions is, what is the typical unit you're looking for? How do you measure this? So density, your units are going to be grams per milliliter or grams per centimeter cubed. So that, that's the kind of unit you're going to be looking for. That's the kind of unit you should expect to see. Mass, we're going to measure mass in grams. So if you're reading in a problem and you see grams, that'll help clue you in, oh, that's a mass. And then volume is either going to be milliliters or centimeters cubed. So if you see that, it'll help you know, where do I put these numbers in that equation? Okay, so go ahead and set up your equation sheet like that for you. That way it'll be really useful all throughout the semester. And as we add more equations to our equation sheet, I will continue to model for you a good way to do that. But of course, it's your equation sheet, so you got to do what works best for you. Okay. Now, something really cool about the density equation is that since it has only 3 variables and the variables are set up in the way that they are, we can use what I like to call the triangle method. And I really like the triangle method because it's really fast, it's really easy to use. Basically, what it's doing for you is it's helping you to know how to rearrange the equation to solve for different unknowns, right? Because when we write it like this, d equals m over v, that's solving for d. That's when I want to know what is density. But sometimes I will know the density and I want to find mass instead. So you should have learned when you took algebra how to rearrange an equation or how to solve for x. But this triangle method just makes it fast and easy. Okay? So if you draw this triangle like this, and the letters have to go in this order, that's really important. You got to know how to put them in the right order. But if you do this, and you can draw the triangle on your equation sheet too if you like it. This line here that separates the top from the bottom, that line is equal to division. This line means divide. And then the line here that's in the middle, that means multiply. Okay, so let's say you need to solve for mass. You do not know what mass is, but you do know the d and the v. Well, since the d and the v are side by side, that line tells you to multiply. You just multiply your density by your volume. Okay, let's say I need to solve for v. I don't know my volume. That's what I want to know. That means I know my m and my d. And this line tells me I need to divide. So I would divide mass divided by density, and that would solve for my volume. Okay? And I'm going to show you how to put this into action in just a minute. Okay? All right, let's do a practice problem. So an object has a volume of 825 centimeters cubed and a density of 13.6 grams per centimeter cubed. Find its mass. All right, so first, let's take a look at what do I know? What information is provided to me in this problem? Okay, I know my volume because it says the word volume, and it's an expected volume measurement. It's centimeters cubed. Okay, so I know that. What else do I know? I also know my density. My density, because the word is right there, 13.6, and it is a typical unit expected for density, grams per centimeters cubed. Okay, what do I need to know? Well, the question says find the mass. So m is my question mark, or if you want to use the letter x there to stick with your algebra, m equals x, that's what I'm solving for. Okay, now at this point we only have one equation, d equals v over m, right? So I now know that this is the equation I'm going to use. But as we move forward, I may need to look back at my equation sheet to see what equation has v, d, and m in it. Okay, so just go ahead and get used to this process. All right, so I have seen what I've been given. I know what I've been given. I know what I need to do, and I know what equation I need to use. So next, I'm just going to plug it in. Okay, now notice here, what I don't know is the m. So if I put my little triangle here, I don't know m, so I covered that up. But I do know d and v. So what is the triangle telling me to do with d and v? Remember that this line means multiply. So I need to do d times v. Okay, so let's go ahead and set that up. Okay, so my d, I can look, 13.6, write out my units so I can keep up with them, multiplied by my v, 825 centimeters cubed. Okay? And I'm just going to type this into my calculator, 13.6 times 825. I'm going to get 11,220. Now, we got to keep up with our units. What units should I have? Well, if we look here, remember that this little slash, this means grams is on top and centimeters cubed is on the bottom. Okay, and remember in algebra, when there's something on the top and something on the bottom, they cancel. So those centimeters cubed cancel off, and I'm left with grams. So let's analyze my answer. First off, was I expecting such a big answer? Well, I'm multiplying a really big number, 825, by a number bigger than 1. So yeah, I can expect a big number. And I did get a big number, so that seems good. And then when I keep up with my units, I'm left with grams. Was I expecting grams? If I look at my equation sheet, I see that mass is usually in grams. So that is expected. So I can analyze my answer and say, yeah, I think that this is a good answer. I think I did a good job. Okay, let's do another example problem. So a liquid has a density of 0.87 grams per milliliter. What volume is occupied by 25 grams of the liquid? So again, let's go through and see what information I was provided with. Okay, right here in the beginning it says it has a density of, so I was provided with a density. And then it says what volume is occupied. So that's my unknown. That's what I want to find. What is my volume? And then by 25 grams. Now I know that's my mass. They never said the word mass in the problem, but it's grams, and I know that grams goes with mass. Okay? So I look at my equation sheet and I see what equation has a D, a V, and an M. It's my density equation, so I'm going to write my triangle here. This time I don't know the V. I'm solving for V. So if I cover that up, what's left? M divided by D. So let's go ahead and set that up. Okay, M divided by D. Just plug in my numbers. My mass was 25. My density was 0.87. Again, I'm keeping up with my units. And now I have grams on top of the line. I have grams below the line. Those are going to cancel off and disappear. They canceled each other out. I'm left with milliliters. So type this into my calculator, 25 divided by 0.87, and I get 28.7 milliliters. Okay, analyze that answer. Was I expecting that number? Well, I'm dividing 25 by a number smaller than 1. So that means my answer is going to be bigger than 25, and it is, so I think I did good there. And then since my grams canceled off, I was left with milliliters, and volume is measured in milliliters or liters, so that is also expected. So I think I did a good job. Okay, so this is how you work those problems. If you do not understand what we are doing here, you do not understand how to do this, or you did not get these answers when you worked along with me, contact me, get me to help you, okay? I am here to help. We can work on it one-on-one so that we can get each other on the right page, and then you can move forward and do some density independent practice.